right? And then everything else is going to be sort of steps. Okay, so if distance less than 8,000, then I want to populate. So my new color array is what I want to populate. When I say new byte, by default all the values are 0, right? So what I'm going to do is I'm going to populate them in terms of red, green, and blue channels, or blue, green, and red channels, because I know blue gets stored first, green gets stored next. And that's why I create this blue offset, green offset, and red offset. So the way I'm going to do it is, let me show you what I'm doing. So say for instance, if somebody's really close to the connect, I want them to be painted in blue. And if they get a little farther away, I want them to be painted in green. And if they get a little farther away, I want them to be painted in red, right? So the way I would put it up is probably something like color of color index plus blue offset equals 255, right? Which basically means of the 4 bytes that denote the blue, green, red, and blank pixel, I'm just choosing the blue pixel alone and filling that with a channel of 255, which means it'll make that whole pixel light up in blue. So I'm going to basically do the same thing here, but instead of blue offset, I'm going to say green offset and red offset. The reason I use these offset colors instead of just saying +1 or +2 is for readability, obviously. That's all I'm doing. I'm adding +1 or +2, but for readability, it kind of helps. So I think that's it. So what's happening now is, let me remember to increment my color index by 4, because for each pixel, I'm jumping 4 pixels, right? And then what I'm going to do is I'm going to come in here, I'm going to say image2.source equals blah, blah, blah. All of this is fine, BGR is fine. Except now, here, I'm going to have it render the color array. And I know that pimage.bytes per pixel, because it's a depth map, would have normally returned 2. But I'm using a BGR32 format, 4 bytes per pixel, so I'm going to manually choose 4 here. But I think that should basically be it. So let's walk through what we're doing. And you know what's funny is, I think that's it. Yeah, let's walk through what we just did. Quick summary of what we just did. For depth frame ready, we did the exact same thing as before. We read the image frame and got the image from the image frame. But instead of displaying it directly on the screen, it was resulting in mostly a super dark image. What we're trying to do is basically read the distance value for each pixel, and based on the distance value of each pixel, we're coloring that pixel. So what it's going to basically do is give us a histogram, if you will, on the screen. All the closer objects will appear blue, slightly farther off will appear green, and far off objects will appear red, and anything beyond that will appear black, right? So that's basically a color-based histogram that we are creating. And so let's see what happens. It's erroring out. Okay, what's the problem? Maximum index was outside the bounds of the array. Okay, let's see. Color is a byte array, and it is 76,800 long. Color index is already at 768. There's some problem somewhere.
Sorry, so times 4.
Times 4? Exactly. Thank you very much. So now, hopefully, okay, there it is. I think it's working. So let's do a quick test. So if I'm super close, right? You can see my hands here, but the depth sensor cannot read my hands because it's less than 850 millimeters. If I keep coming a little farther, my hands will become blue, or I'm actually blue. So this means I'm between, let me see, okay. At this point, I'm between 800 millimeters or so. Now if I move a little farther away, from blue I should become green. There I am. I'm blending in with this. In fact, let me turn it this way. Let me turn it towards you guys. There's a pretty beautiful histogram, right? I mean, first row, if I came stand in the first row, I'm all blue. Next row is all green. The row after that is all red. And the row after that, from there on till the end, is all black. It's just a simple color-based histogram of the depth data ratio. Yeah? And it's, even though it seemed like it took us a long time, I hope you see the code is pretty simple. And this is where, at this point is where it will be super helpful to sort of use frame numbers and timestamps to coordinate. If you're doing especially something to coordinate between the vision camera and the depth camera, that was the time to use those to sync between the two. Right? How are we doing on time? 3:40 to 21 minutes? Okay. 21 minutes? So great, and I think we have 20 minutes, so I think I'm going to step it up a little bit. I want to show you one more demo, actually. So what I'm going to do is I'm going to move this slightly closer. So right now, I want to show something. When I stand in front of it, obviously under a meter, I'm all black, blue, green, and red, and black again, right? But here's the point. At no point does it do any sort of human detection, right? It's basically just doing basic depth map information. I think the next step I want to show you really briefly, and this I think is very exciting. This is going to be the feature you'll probably end up using the most in the Connect, is instead of just using depth, I want to show you how you can use depth and player index, right? So that's the only change I'm going to make here. And then there's one more change I have to make. In depth stream.open, image type should also be changed to depth and player index, right? This is the only two changes that we need to make. Everything else, the depth, frame ready, everything else can stay the same. Now here's the problem though. If I ran this as it is, let's run this as it is. You see this, our histogram channel is broken. It's really not showing anything, it's all showing black because none of the distance ranges are working well, right? It's not working properly. Anybody know the reason why that is? Because all the values that we're getting are greater than 4,000, right? Because what's happened now is when we sort of, let me go to slides for just 1 second. Okay, the first time we ran this, we just used depth alone, which means data was only represented in 12 bits, which means when we reversed order and left and sort of ordered, when we left shifted and ordered, the values were between 800 and 4,000. When we use depth and player index, we use 12 bits, but we also use 3 bits to identify the user, right? So what we end up actually doing is we end up using 15 bits, right? And so when we left shift and OR, it basically results in a number close to 32K or something. So that basically means every number is greater than 4K, and therefore it's all black. So that aside, what I think I want to do now is basically code up the application to use depth and player index, which means I want to use the 12 bits. I want to extract the new 12 bits. It's not in the last 12 bits anymore. It's offset by 3. I want to grab those. And I also want to grab the last three bits, because this is going to give me the player index. So let's code that up. It should literally take us about 4 or 5 lines of code. So let's code that up. First, let's fix the get distance method, because this is not going to be the formula anymore to grab the distance. I'm just going to copy paste it so I can make small changes. Now here's what we did earlier. Earlier we just sort of flipped it and ordered it. P1 has 3 digits of segmentation mask, which needs to be thrown out before we can audit. So to throw out the last 3 digits, what I'm going to do is I'm going to right shift this by 3. Right? So what this is going to do is going to take the last 3 digits and throw it out. Now here's the thing. I still need P2 to come all the way to the left before I can audit, but how much do I want it to come to the left? 5, exactly, right? Because P1's moved 3, so instead of making this come 8, I only need it to come 5 because this is already moved right by 3. So exactly right. I mean, if I just make it come by 5, this is my new formula for getting the distance with the segmentation mask turned on. Now if I run this, I think it should be fine. So I'm all blue, now I'm all green, now I'm all red, now I'm all black, right? So fantastic, our app works like before. So that's the only change in formula you need to make. The reason I'm showing this is when you often look at connect samples, you'll see either this formula or this formula, and you need to sort of understand why people are bit shifting left and right and all of that. Once you get that, you're done. Now here's the really interesting part. You know how we're basically doing the measurement here? Let's basically do something like so. I'm gonna basically now extract the last 3 bits from P of I. If P image dot bits, isn't that what we're looking for? P image dot bits I, right? If the lower order bits last 3 digits, and the way I look to see if the last 3 digits, the last 3 bits are set is by ANDing it with 7, right? So 7 is 1, 1, 1 and all zeros, right? So now if I take any number and if I AND it with 1, 1, 1 and all zeros, it basically just extracts the last 3 bits and gives it to me. So instead of doing an if, let me do this. Let me switch on let's do just 2 or 3 cases.